Okay, today we are going to talk about digitizing your watersheds, and so you should start with your map to full extent, and you should have your topo sheet, your watersheds layer, and your streams layer in there. First thing you want to do is change the symbology of your streams layer to be thicker so these are visible. I like to change it to a blue color as well, set it to 3. So now we can see our streams. Some of the kind of starting points for you digitizing your watersheds, things you want to remember is no watershed should bisect a stream or water body, so it should contain an entire stream network, including water bodies, so you shouldn't be able to go in here and bisect that. We're going to start over here down in this area and delineate this one little watershed here. But one first thing that can be useful is determining the outflows from your watershed. So stream networks and where they flow out of your watershed. So this can be done with your drawing tools. So drawing tools is what we're going to rely on, and these are just temporary data that is non-spatial that is going to give you a good idea of where your watershed is. So it's going to emulate drawing on a piece of paper. So we have one outflow here. We're going to change that to here and then just put an arrow to remind us that the water is flowing out of our watershed or out of our atlas sheet at this location. So it seems likely that these streams come together right here, but you're not really supposed to use this, so you should have the outflow be both of these locations. So you want to click this little arrow, go down to line, and create a drawn arrow. Each time you create a new drawing, you do need to click the line tool. These you can also change, if you right click them, you can change the color. And the thickness of the line. So you can make them a little more visible if you'd like. So there we've got some of our outflows. You can do that for all your streams, kind of give you an idea of how many watersheds you're going to have to delineate. The one we're going to start with, as I said in the beginning, is this one down here. So the next step to kind of digitizing your watersheds that I think you went over in class is that you're going to put some you're going to determine some high point locations where there's most likely where there's divergent flow. So you use the marker tool in this case. So marker just puts a point. So we're going to put one up here at this divergent flow area. And it's likely that kind of your watershed will be perpendicular to your topo lines. So it might come down here, and we don't really have another high point in this location, but we need a high point between these two stream networks. So there's probably another one over here, perhaps. And again, you can change the color of these little dots to be a little more visible, make them larger. I like red, obviously, very visible on the map. Green kind of doesn't show up completely well. Okay, so we've got two high points, and we'll kind of find some areas where there's divergent flow, and we can use that line tool again to delineate where this flow kind of happens. So looks like some maybe flows this way down into this little drainage way, and then in the opposite direction we would expect some flow over here down into this stream network. Double click to finish your drawings. And so that you may get varying degrees of leverage out of determining the actual flow with the drawing tools, but the point locations for high points and then likely divergent flow can be very useful for determining your extents, the extent of your watershed. So the next thing you're going to do is start an editor session. Make sure to include your watersheds in that editor session. Go to Create Features, click on the watersheds, and then you're going to start digitizing in the same approach you did with streams, make sure your snapping is turned on. So that has its own toolbar. We'll take that over here. And I want to snap to edges. So this is the last one here, edge snapping, I want that engaged. Because I want to start on the boundary. I want my watersheds to be coincident with the boundary and each other. So we're going to start on the boundary. That's where that text pops up. And then we're going to move along perpendicular to our topo lines up to this point of divergent flow. And then I think right down here is kind of our location for our watershed. And then we'll go up here and maybe should have been a little bit out further up there. So and then double click to finish once I get to my atlas sheet edge. And now we have a finished first watershed. If you make a little mistake, you can delete those. So if you do want to change your watershed in any way, you can always use the reshape tool up here in your editor toolbar. Click that. Start on the polygon you want to reshape. And now we don't want to touch the other stream network, and we're a little too close to that, but just come and bring this out a little bit further. So to give you an idea of, okay, that's our watershed for this particular stream. It's a little small watershed, but just gives us an idea. We want to start with the trace tool. And we're going to come up along the boundary. You just want to click once and then follow the boundary of your previous watershed. Then when we're done, we click again. So it's created vertexes along the boundary. And we click back to the line, straight segment. So we're going to go up this Peck Hill, perpendicular, then kind of come over here. And now, again, like I said, not perfect, but it's going to just show you some of the mechanics of digitizing your watersheds. And then we're going to go across here, and you're going to finish on your boundary. We actually want to turn edge snapping back on, and the edge of our boundary here. So now that we've put one there, we want to put one on the corner of our atlas sheet boundary, and then one more vertex all the way at the bottom. And now you may say that that should be 2 watersheds, and that's okay. We want to just create a big watershed to show you the mechanics of getting that boundary and follow in tracing your other watersheds. If you do have some issue, an error like this down here where your watershed doesn't completely follow the boundary, use your reshape tool. Start within it, go down to the atlas sheet boundary, scroll over, and then finish. Next, we're going to look at doing some of those calculations in your data tables for your watersheds. So you can see here, our watershed has there are 2 watersheds in our data table. Not surprising, we digitized 2. We have a couple variables here. We have watershed name, which since we're in a editor session, we can just double click and write a name in here. These are text fields, but I can just put them as 1 and 2. And then watershed area, we want to calculate geometry. And for your watersheds, you actually want acres. So you want to hit this drop-down menu and calculate acres. Don't be confused with areas. They can be, if you look very quickly, you can see that you can not notice the difference between the two. We want acres, and this will be used in our calculating our stream density. You want the feet of the streams in acres. So you can see that for these watersheds, I haven't followed the streams through the water bodies, so these wouldn't be correct for your calculations. You want to have all streams follow through the water bodies, so they would connect into the middle of this pond here. Make sure you do that on your calculations. So once you're done with that, you want to stop editing. We want to save our edits. And then next you're going to add fields. So for these purposes, you want to add fields that are, I haven't given you exact names in the workflow, but you want to add fields that are short integer for first order streams. These are going to be a tally of all the first order streams in your watershed. Then you want to add a field for second order, so on and so forth. You want to add a field, this one can probably be float, for stream dense. They will abbreviate your field if you get too long in your name. Then we also want to add a field for each of your bifurcation ratios. And these should be float as well. And you could have these 1 by 2, or in this case 2 by 3. Click OK. And so if you do make a mistake, such as that one, you can always delete a field. Right-click on it at the column heading and delete field. Click yes. And it'll be gone from your attribute table. Add field. My mistake was I had it as a short integer. The next thing you want to do is you want to select, so you can select your watershed just with the select features tool. Click on one, and we want to calculate all the first order streams in this particular watershed. So to select all streams in this watershed, you can do select by location, select features from streams, use selected features in the watersheds. So we have one feature, and then apply. So you can see now we've highlighted all our streams. If we open up our stream data, we have the number of streams in each of these that are first order, second order, third order. And we can just quickly calculate, we can just quickly add up these. So we have 3. If you want to use selects further, you can select by attribute. Do streams, do stream order, equals, get unique values, 1. So now we have, okay, so first you're going to select by location. So first you should use the select tool, click on your watershed, select by location, select from streams, use selected features in watersheds. Click OK. So now we've selected all our streams. If you want to further select, you can select by attribute. Instead of create a new selection, do select from current selection. Stream order equals get unique values 1, apply. So you can see down here we have 23 first order streams. Now, be careful in your own data, because if you've created a stream segment that if you've created multiple streams or multiple segments, such as if you cut this one in half, this particular stream in half, and it's actually 2 segments in your data, be careful counting that as 2 stream segments for your stream order calculations. But for this data set, it's coded up well, so we have 23 first order streams. So we can go back to our, I'm just going to show you for first order and second order in this case. So we can go back to our first order streams, click here. If you are not in an editor session, which I'm not, you can just do field calculator, go yes, and we want to make these 23. So you can see that calculated our first order streams to be 23. We can do the same now for our second order streams. Again, select your watershed, select by location. It saves your defaults from your last selection, so you can just click OK. We've selected all those streams again. select by attribute, stream order 2 this time. Instead of create a new selection, make sure you select from current selection, click OK. So now you see we have 7 second order streams in this watershed. So again, I'm going to come here and calculate my second order streams. They would be 7. So now we can calculate our bifurcation ratio for our first and second order streams. Field calculator. This can be done, we know it's just 23 and 7, but if you wanted to calculate it for multiples, you could just put those two fields in. First orders divided by second order. And now you get 3.28 is our bifurcation ratio for this first watershed here. To calculate your stream density, you are going to divide the total length of all streams in your watershed by the total acres of your watershed. So first select your watershed, do another select by location, selecting all those streams, click, it should save your defaults from last time, click OK. You see we've selected all our streams, looks good. Next we're going to go to our streams dataset. See we have our stream length here, it's been calculated in feet. We can just right click, do statistics, and then we'll have our sum. So that's our total length of stream in this watershed. We go back to our stream density, go to field calculator. So we want to paste our total length. We want to divide this by our watershed area and click OK. So now we have a 25 feet of stream per every acre of watershed. So that's our stream density calculated. So we've calculated all of our all the basic attributes that you're going to need for your table. You can see how it can be useful to do these calculations in GIS. You can quickly do it, especially if you've coded up and digitized your streams and watersheds correctly. So these can then be copied and pasted into a Word table or Excel sheet, whatever works best for you. That's the end of our watersheds video. Thanks for watching.